In this example, we're going to look at a set of ordered pairs and determine if they are a function, and then find the domain and range. In this first example, we have 5 ordered pairs, and we start first by looking at the x values. So when I look at the x values, I see that I have 1, -2, 0, 1, and 3. If I want to determine if this is a function, I'm going to look to first see, are there any x values that repeat? And here I see that 1 is in the first and in the fourth ordered pair. Now I want to make sure that those x values, those inputs, are going to the same output. If they're going to the same output, then we're fine, it's still a function. But if they're going to different outputs, then this is not going to be a function. And in the first order pair, 1 goes to -3, and in the fourth, 1 goes to -6. So because of this, we can say, no, not a function. And why? We would say because 1, the value 1, has 2 different outputs. Okay, even though it's not a function, we can still give the domain and range of this relation. So for the domain, we are simply listing the x values, the inputs. I'm going to put them in order from least to greatest. So that's -2, 0, 1. I don't need to write 1 twice, even though it appears twice. It's still just one value, and then 3. And then for the range, again, we're going to go from least to greatest. So the smallest y value I see is -6, then -3, then there's 4 twice. And note that that is not actually a problem for it being a function, the fact that there's 2 repeat outputs. It's just really a fact that there's 2 repeat inputs that have different outputs. In this next example, we again want to start the same way. Is this a function before we even assess the domain and range? So let's look at the inputs. 3, 7, -6, 8, and 2.5. None of those repeat, so there's not going to be an input that has more than one output. So that's good. And we would also notice that every input does happen to have an output. Do not be concerned here about the fact that 4 appears twice. Just because 3 goes to 4 and -6 goes to 4, that's okay. We're still allowed to have that and it still be a function. So we'd say, yes, this is a function. And we would say because all inputs have one and only one output. Okay, so let's look at what the domain is then. We're looking at all the x values, the first number in the ordered pairs. Let's go from least to greatest. So I see a -6, I see 2.5, I see 3, 7, and 8. For the range, the smallest value I see is -5, and then it looks like 2, 4, and 11. And so this example is a function. Again, don't worry about those 4s as the repeat outputs. They do not break any of our function rules.